Today, we're diving into something that sounds kind of impossible, a firewall that's not for a single computer, but for the entire cloud. It's a completely new way of thinking about security, and it tackles one of the absolute biggest headaches in technology right now.
You know, for the longest time, securing a company was a bit like protecting a medieval castle. You just built a really strong wall around it. Simple. But here's the thing. Your company's data doesn't live in one castle anymore. It's spread out across a dozen. Some of it's with Amazon, some with Google, some with Microsoft. Those old walls, they're basically useless now, which leads to a huge question. How in the world do you protect a kingdom that has no borders?
Well, to even start to answer that, we've got to get a handle on this new landscape. It's not a neat little kingdom anymore. It's more like a complex, sprawling maze of cloud services, and it has totally changed the game for cybersecurity.
Right. So this was the classic model, perimeter security. Everything you cared about was on the inside, all the scary stuff was on the outside, and you had a big, powerful firewall standing guard at the gate. It was pretty straightforward, it worked, and for a good long while, that was all you needed.
But this is the world we live in now. It is not one single fortress. Think of it more like an archipelago of data islands, and each island has its own rules, its own native environment, and, its own set of potential vulnerabilities. That whole single wall idea, it just doesn't compute anymore.
And this new reality brings with it a whole host of brand new dangers. Take something called identity sprawl. That's what happens when you have user accounts and permissions scattered all over the place, making it almost impossible to know who has the keys to what. You add in fragmented management tools that don't talk to each other, and suddenly you've swung the door wide open for these new cloud-native attacks that your old-school security can even see coming.
So all of this is pointing to a really big problem. The tools we have to protect ourselves are falling way behind the curve of how we actually use the cloud. And that's creating a dangerously wide security gap.
And look, don't just take my word for it. This is a central finding from the research itself. The paper literally calls out a key research gap, highlighting this urgent, pressing need for a security system that isn't stuck in one place, but can intelligently protect data no matter where it lives.
And here's that gap, laid out plain as day. On the left, you see our current tools. They're often locked into one vendor, like AWS or Azure. They force you into performance trade-offs, and they just can't respond in real time across different clouds. But on the right, that's what we actually need. Something that's unified, that's high performance, and that's completely automated. It's a pretty stark difference, right? So, how do we bridge that gap? Well, this research proposes a really clever solution. A new breed of intelligent firewall. One that was designed from the ground up for this messy, multi-cloud world. Let me introduce you to SIF-CCA. It stands for Serverless Intelligent Firewall with Cross-Cloud Adaptation. And honestly, the name tells you pretty much the whole story. Serverless means it can scale up or down instantly and efficiently, and cross-cloud means it's built to work everywhere all at once.
Okay, so that's the big idea. It sounds awesome, but how does this thing actually work under the hood? Let's take a look at the architecture.
So this is the blueprint. At its heart, it's built on 3 core pillars that all work together. You've got a unified control plane that acts like the rulebook for everything. You have the AI-powered firewall itself, that's the brains. And you have a serverless system that acts as the reflexes, all working in concert to protect resources, whether they're on AWS, Azure, or Google Cloud.
Let's start with the brains of the operation. It uses this really cool hybrid AI that I like to think of as a 2-person detective team. One detective, a model called XGBoost, is an expert at spotting individual suspicious clues. It figures out the what of a potential attack. Its partner, BiGRU, is brilliant at seeing the big picture, piecing those clues together in the right order to understand the full story, the how. Together, they get a way smarter, way more complete picture of a threat than either could alone.
Next up, the reflexes. This is that serverless part we talked about. So when the AI brain spots a threat, it doesn't just, send you an email alert. No way. It instantly triggers these automated functions, things like AWS Lambda or Azure Functions, that can react immediately, at massive scale, across any cloud. It's like an automated, super fast immune system for your entire cloud setup.
And the final piece of the puzzle is the guard. This is a universal rulebook that runs on one simple but incredibly powerful idea: zero trust. It starts by assuming nothing is safe by default. Not a single request, not one action gets a free pass. Everything has to be verified, every time. This creates a consistent, ironclad layer of security everywhere, no matter which cloud provider you happen to be using. Okay, this all sounds fantastic in theory, right? But the real question is, does it actually hold up in practice? Well, to find out, the researchers put SIF-CCA through the ringer, testing it against industry-standard cybersecurity datasets and attack simulations.
And the results? They're really, really impressive. Right out of the gate, SIF-CCA hit a 98% accuracy rate in detecting threats. I mean, that is an absolutely elite level of performance. Now, 98% is a great number on its own, but context is everything, right? SIF-CCA doesn't just perform well, it clearly outperforms other well-known machine learning models, from random forest to advanced neural networks like CNNs and LSTMs. That hybrid AI detective team we talked about, it's pretty clear it gives this model a serious edge.
And this visual just illustrates it perfectly. This is called a ROC curve. And really all you need to know is that the perfect model would have a curve that goes straight up and straight across, hugging that top left corner. That means you get super high accuracy with very few false alarms. And if you look, SIF-CCA's dark teal line gets closer to that perfect corner than any of the others.
But accuracy is only half the battle. In cybersecurity, speed is everything. A slow response might as well be no response at all. Well, SIF-CCA clocked an average response time of just 135 milliseconds. To put that in perspective, that is literally faster than the blink of an eye. That's fast enough to shut down an attack while it's happening, before any real damage is done.
And finally, what about that zero trust guard? Does it actually apply its rules consistently across all these different environments? The data says absolutely yes. Whether it was running on AWS, Azure, or Google Cloud, SIF-CCA maintained over 99% policy consistency. This is huge. It proves that the whole unified control plane idea really works. You get one reliable security standard everywhere.
So what does this all add up to? Well, this research isn't just about a single new tool. It's really proposing a fundamentally new blueprint for how we should all be thinking about cloud security from now on.
And that new blueprint really boils down to three key things. First, we need intelligent, AI-driven security that can learn and adapt on the fly. Second, we need a universal way to handle identity and rules that works everywhere, no matter the provider. And third, the whole thing has to be automated, responding to threats in real time. This is the new paradigm. Which brings us to a final, pretty provocative thought. The old model of building bigger and better walls has kind of failed us in this new, spread-out world. So maybe as we move forward, the ultimate form of security isn't about the walls at all. Maybe it's about getting rid of the idea of walls altogether, and instead just learning to trust absolutely nothing by default.